Let us see today the heading Poisson process. And x of t represents the number of occurrences or arrivals in a certain interval 0, t. Okay? In a certain interval, if I write x and x of t, it denotes, listen here, number of arrivals or number of occurrences in the interval 0, t. Okay? Then the discrete random process. This Poisson process is a discrete process. Okay, discrete random process. X of t is called Poisson process if the following postulates are satisfied. Okay, postulates. If the following postulates are satisfied. The first postulate, probability of one occurrence in the time t, in the interval t, t plus delta t. Probability of one occurrence. Listen here. You know what is x of t, right? X of t denote number of occurrences in the interval 0, t. If you consider this interval t, t plus delta t. Listen here. For example, see if t may be 0 and delta t the small change in time, which may be 1 second or 2 second, okay? Or some 5 second, a small change in time, 0, 1. So if you consider this interval 0, 1, there may be one occurrence in this interval or there may be no occurrence in the interval, okay? So there are only two possibilities. There may be no arrival in this interval or maybe one arrival in this small interval, okay? So probability of one occurrence in the interval t, t plus delta t is lambda into delta t. Second postulate, probability of zero occurrence in the small duration. Zero occurrence in the small duration is 1 minus lambda into delta t. Then the third one, see, probability of two or more occurrences, okay, in the interval, in this interval is 0. So why it is 0? Probability of 2 or it is very small interval, okay? A small interval. There may be no arrival in this interval or maybe one arrival in the interval, right? 0, some 1 second or some a few microsecond, right? So it is a small change in time, right? So there may be no occurrence or one occurrence in this interval. Probability of having two or more occurrences in the small duration of time is, a small interval of time is 0, okay? Fourth postulate, x of t. You know x of t denote number of occurrences in the interval 0, t. You consider the interval prior to its interval. You consider the interval after the interval. The number of occurrences here is independent of the interval prior to the interval 0, t and after the interval 0, t. It is independent. It will not depend on these intervals, okay? So the number of occurrences is independent, okay? Independent, and we need not bother about the interval prior to its interval, after the interval, okay, which is fourth postulate. Then fifth one, listen here, you consider the interval t0, t0 plus tau, okay, like t, t plus delta t. I consider t0, t0 plus tau, which is similar like it is if it is t0 is 0 and t1 may be some 2 second, 5 second, right, 1 second, right. So listen here, let us consider t0, t0 plus tau. See, the probability of the event, right, that occurs some specified number of times. Listen here, the probability of a certain event which occurs specified number of times in the interval t0, t0 plus tau depends only on tau, not on t0. Okay, that is what is the meaning. Listen here, what is the time duration in the interval? 1 second time duration. Right, 1 second, 1 minus 0, 1 second. Similarly, time duration is t0 plus tau minus t0, which is tau. The time duration is tau. So the event which occurs in the interval depends only on tau, not on t0. In case if you see, if t0 is some 2 second and t0 plus tau is 3 second. See, t0 takes 2, t0 plus tau, tau takes 1. So listen here. And the event which occurs some specified number of times in this interval depends only on tau. What is tau here? 2 plus 1. 1 is tau, right? It depends only on this 1 second, okay? Tau, not on t naught, okay? This is t naught plus tau. So the event which occurs, right? The event which occurs a specified number of times in the interval 2, 3 depends only on this 1, not on 2, okay? Which is fifth postulate. The random process x of t is called Poisson process. The random process x of t is called Poisson process if it satisfies the following postulates. Okay. What is x of t? X of t represents the number of occurrences in the interval 0, t. You should know thoroughly about x of t. Okay. X of t denote the number of occurrences in the interval 0, t. Okay. So let us see the postulates. First one, you know 0, t. If you consider t, t plus delta t, for example, t is 0, delta t is 1. 1 second maybe, okay? A very small interval, right? Small, when you find the duration, it is very small. The duration is small here, okay? So there may be 1 arrival in this interval or maybe 0 arrival in this interval. There may be no arrival. There may be no occurrence in the interval or 1 occurrence in the interval. So probability of 1 occurrence in the interval is t, t plus delta in the interval, which is lambda into delta t. And listen, the delta t is the small change in time. Lambda is the arrival time, okay? Arrival rate of arrival. Lambda is the arrival rate, okay? So probability of 0 occurrence in the interval is 1 minus lambda into delta t. Probability of 2 or more occurrence in the interval is 0. Because very small duration, it is not possible to have 2 occurrences or more than 2 occurrences. That is, these are all postulates, okay? These are all postulates which you have to keep in mind. Okay? And fifth one, we know x of t denote number of occurrences in the interval 0, t. See, the number of occurrences are independent. It will not depend on the interval prior to this interval or after the interval. Okay? And if you consider t naught, t naught plus tau, the occurrences, listen here, the event, or we say the event which occurs specified number of times in the interval. So there may be a event which occurs specified number of times in the interval. See, whose probability depends only on tau, not on t naught. Listen here, the probability that certain event which occurs in this interval, right, which occurs specified number of times in this interval depends only on tau and not on t naught. Okay. So these are all 5 postulates. If these postulates are satisfied, then the random process x of t is a Poisson process. Okay. Let us see now probability law of Poisson process. The probability law for Poisson process is Pn of t is equal to P of x of t is equal to n is equal to it is lambda t whole power n e power minus lambda t by n factorial. Okay, where n takes values 0, 1, 2, etc. So we already know what is P of x of t equal to n, right? N occurrences in the interval 0, t. See, probability of n occurrences, n arrivals in the interval 0, t. Arrivals here denote maybe phone calls or some other arrival, right? So number of phone calls in certain time interval 0, t. Okay, which is P of x of t equal to n. So let us derive this probability law of Poisson process. This is lambda t whole power n e power minus lambda t by n factorial. Okay, let us prove it. Proof. So we know, listen here, I write in words, P of x of t equal to n is probability of n occurrences in the interval 0, t. Okay. Next, let us consider P of x of t plus delta t, which is n. That is, what's the meaning? Probability of n occurrences in the interval 0, t plus delta t. Okay, the same meaning, right? But the time interval is 0, t plus delta t. Okay, so now listen here. Let us take this interval 0, t plus delta t. Right? Delta t, the small change in time, you know, right? It is rough work. 0, t plus delta t. Let us split the interval into 0, t, t plus delta t. For example, it may be 0, 1 hour, 1 hour, some 1.2 second, 1.5 second, right? So 0, let us split the interval. So for example, it may be 0, 1 hour, and this may be 1 hour, 1 hour 2 second, 1 hour 2 second. Okay, 2 second. So it denotes 1 hour, right? Let us assume. Okay, so if you see in the interval 0, t plus delta t, there are n arrivals, n occurrences. So you know postulates of Poisson process. There are n arrivals here, right? And when you find time interval, it is 1 hour. If you time duration, it is 1 hour. If you find time duration, it is 2 seconds, right? So very small duration, right? There are n occurrences totally in these two intervals. So there are only two possibilities. Here there may be one arrival or zero arrival. Okay, there may be one arrival or zero arrival. Probability of two or more occurrences in the interval is 0, right? We have already studied, right? So it may be one arrival or zero arrival. If there is one arrival, other n minus 1 arrivals will be in the interval 0, t. So that totally it will become n occurrence. Okay. So we know postulate of Poisson process. Probability of 0 occurrences in the small duration of time. Probability of 1 occurrences in the duration of time. Probability of 2 or more occurrences in the interval, right? Which is 0. So it is not possible to have 2 or more occurrences in this interval. So if there is one occurrence or one arrival, then the rest to n minus 1 arrival will be in the interval 0, t. So that when you add, it will become n occurrences. If there is no occurrence in this small duration, then all n occurrences will be in the interval 0, t. Okay, so these are the only two possibilities, right? Let us write now, listen here, the same p of x of t plus delta t equal to n, which becomes p of x of t plus delta t equal to n, right? Which is equal to, I consider this and I consider this rough work. See, this n occurrences become probability of n minus 1 occurrences in the interval 0, t and 1 occurrence in the interval t, t plus delta t. Okay, or it is or probability of n occurrences in the interval 0, t and 0 occurrence. 0 occurrence in the interval, right? And t, t plus delta t. Okay. So now let us write. I know I have already told you how to rewrite this, right? How to rewrite this? P of x of t equal to n is Pn of t. Okay, which is Pn of t. So let us rewrite it as Pn of t plus delta t is equal to probability of, right? It is n minus 1 occurrence, right? N minus 1 occurrence in the interval 0, t can be written as x of t is equal to n minus 1, right? P of x of t equal to n minus 1. Okay. They are independent, okay? The occurrences are independent here. So it's a probability of one occurrence in the interval that we studied, right? Probability of one occurrence is lambda into delta t plus. See, since they are independent, I can write like this. Probability of, okay? If you want, you can have here bracket into lambda into delta t. Similarly, probability of n occurrence in the interval can be written as Pn of t. Probability of zero occurrence, right? Since the occurrences are independent, I can write probability of zero occurrences 1 minus lambda into delta t. Okay. P of x of t equal to n minus 1 into lambda into delta t plus Pn of t into 1 minus lambda into delta t. Okay. Next it is, so this can be written as Pn minus 1 of t. Am I right? This can be written as Pn minus 1 of t. Okay. Now let us do, see, I multiply this. See, Pn minus 1 of t into lambda into delta t, right? Lambda into delta t plus Pn of t minus Pn of t into lambda into delta t. See, I have multiplied this Pn of t into Pn of t minus Pn of t into lambda into delta t. Next step, see, Pn of t plus delta t minus Pn of t is equal to Pn minus 1 of t into lambda into delta t minus Pn of t into lambda into delta t, where I can take lambda into delta t common, hence Pn minus 1 of t minus Pn of t. And I can write it as Pn of t plus delta t minus Pn of t by delta t equal to lambda into Pn minus 1 of t minus Pn of t. Okay. Now listen here, when delta t tends to 0, when delta t tends to 0, by definition of differentiation, delta t tends to 0, this one, which will become Pn dash of t, by definition of differentiation, okay, which is lambda into Pn minus 1 of t minus Pn of t, okay, which is our first equation. So what is our aim actually? Our aim is to get the answer of Pn of t, okay, that is our aim. See, what is the aim? Our aim is to prove Pn of t is this one, okay, that is probability of n occurrences in the interval 0, t is this one, that is the aim. So that's why I started with Pn of t, then Pn of t plus delta t, then I proceeded. I have got answer for Pn dash of t. Okay, now in order to get Pn of t, next step, let us assume the solution of Pn of t be this one. We shall get the solution, okay. We know what is the solution of Pn of t, which is lambda t into lambda t whole power n into e power minus lambda t by n factorial, okay, which is Pn of t. Let us assume solution, okay, not this solution, more or less like this, let us assume, okay, let us assume, let the solution be, let us assume Pn of t is equal to lambda t whole power n into f of t by n factorial, okay. Actual solution is lambda t whole power n e power minus lambda t by n factorial. So I consider solution be this one. So more or less like our exact solution. But if I prove f of t equal to e power minus lambda t, the proof is over, okay. So let us assume this be the solution of this first equation. This be the solution of this first equation, okay. And next step, since I have here Pn dash of t and this is Pn of t, okay, I find Pn dash of t now. Differentiate it. Pn dash of t equal to, and what it will become if I differentiate, I can take lambda power n by n factorial outside, UV method. Keep t power n, differentiate f of t, plus keep f of t, differentiate t power n. Okay. And which can be written as, I know what is, I think I'm right, okay. So it is C, lambda power n, t power n, f dash of t by n factorial, plus lambda power n t power n minus 1 af of t by, we have n already, right, divided by n factorial. You know n factorial is, in n factorial 1 into 2 into 3 into this is 1 into 2 into 3 into up to n is n factorial. Its previous term is n minus 1, right? 2 into 3 into n minus 1 into n is n factorial. So if you write this as 1 into 2 into etc., the term n get cancelled. Okay, n get cancelled. And the rest, this become up to this. This become n minus 1 factorial. Okay, so I am going to rewrite this, which is C lambda power n t power n f dash of t by n factorial plus n get cancelled, right? Lambda power n t power n minus 1 f of t by n minus 1 factorial. Okay, and this, let us assume this be third equation. Okay, I have Pn of t and differentiated, I got some answer which I written as third equation. Okay, let us see first equation now. See first equation, I have Pn dash of t, I have Pn of t. Alright, if I know Pn of t, when I replace n by n minus 1, I get Pn minus 1 of t. So I substitute all. I know Pn dash of t, right? This is Pn dash of t. And I assumed the solution and I got Pn dash of t. I substitute it here. I know Pn of t, right? Pn of t, my assumption. I substitute it here. When I know Pn of t, I can replace n by n minus 1. I will get Pn minus 1 of t. So let us see how this first equation becomes. Okay. See. First equation becomes, what is Pn of t? Pn of t is lambda power n t power n f of t by n factorial. Okay. Okay. What is Pn dash of t? This one. So first equation, left hand side Pn dash of t, right? Am I right? First equation left hand side Pn dash of t. Okay. So let us take this Pn dash of t in the left hand side. Lambda power n t power n f dash of t by n factorial plus lambda power n t power n minus 1 f of t by n minus 1 factorial, which is equal to what it is? Lambda into Pn minus 1 of t minus Pn of t. So we have lambda into, what is Pn minus 1 of t? This is our Pn of t. When I replace n by n minus 1, I get Pn minus 1 of t. See, lambda power n t power n f of t by n minus 1 factorial minus lambda power n t power n f of t by n factorial. Am I right? Pn, when I replace n by n minus 1, right? I have not replaced here n minus 1 in the numerator. Okay. Pn minus 1 of t minus Pn of t. Pn minus 1 of t and Pn of t. This is Pn of t. Let us simplify this, okay? Let us simplify this. So when let us keep this term as it is and this term as it is, right? Here I multiply this lambda. Lambda power n minus 1 into lambda is lambda power n. When base same, we add powers. T power n minus 1 into f of t by n minus 1 factorial. When you multiply lambda here, lambda power n plus 1. Lambda power n plus 1, t power n f of t by n factorial. These two are same, they get cancelled. I have written what in the left hand side and right hand side. In the right hand side, it is lambda power n plus 1, which can be written as lambda power n into lambda. So they get cancelled, right? The sum of the terms get cancelled. It becomes f dash of t equal to minus lambda into f of t. Then I write f dash of t by f of t equal to minus lambda. So f dash of t is differentiation of f of t, right? Divided by, right, f dash of t by f of t, right? And when I integrate, listen here, I integrate it. Because differentiation of f of t is f dash of t dt. I have integration sign. You know, it is differentiation. Listen here, integration, differentiation are of reverse process, right? They are of reverse process, right? So we know it looks like integral dx by x. It looks like integral dx by x, which is log x. Log x, okay? When I have to integrate here also, integrate with respect to t, okay? Both sides I integrate with respect to t, which is right? I think I'm right, which is minus lambda t plus integration constant c. Okay, so I want f of t answer. So I take base e both sides. Take base e both sides. We know e power log x is x, right? So it is f of t is equal to e power log x is x. F of t is equal to e power minus lambda t into e power c. Okay. I have already assumed the solution, okay? So if I prove f of t equal to e power minus lambda t, the probability law, the proof is over. Proof is over, okay? So I have to prove f of t equal to e power minus lambda t. See, I assume e power c is some constant k, e power minus lambda t. Okay, assume this. Okay, k equal to. And what I need to prove is f of t equal to e power minus lambda t. If I prove k equal to 1, it is over, right? Proof is over. Okay. Let us write it as fourth equation. Fourth equation, okay. Now in order to prove k equal to 1, I consider Pn of t equal to lambda t whole power n f of t by n factorial. The solution which I assumed, right? Second equation. It is second equation which I assumed. I consider this, okay? In order to prove k equal to 1, I consider this. Listen here, let us find what is P naught of 0. What is the meaning P naught of 0? Probability of 0 occurrences in the interval 0, 0 is the meaning, okay? Probability of 0 occurrences in the interval 0, 0 is the meaning, okay? So now I write here, I put n equal to 0, t equal to 0. So when n is 0, it becomes 1. T is 0, f of 0. And 0 factorial is 1. Lambda t whole power 0 is 1. 0 factorial is 1. It is f of 0. Okay. So we know probability of 0 occurrence in 0, 0 is 1 sure event. It is sure event, right? There will be no occurrence in the interval 0, 0, which is a sure event. So it is 1. So 1 is f of 0. Okay. So let us now consider f of t equal to lambda into e power minus, k into e power minus lambda t, which is our fourth equation. Okay. Now what I do is, when t is 0, what I have when t is 0, it is k. Okay. When t is 0, it is k. Just now I proved f of 0 equal to 1. So k is equal to 1. So when k is 1, how our fourth equation becomes f of t equal to k into e power minus lambda t. K is 1, so it is e power minus lambda t. Now you substitute it in the second equation, which I assumed that solution Pn of t equal to lambda t whole power n e power minus lambda t by n factorial, right? So which is the probability law of Poisson process, okay? Probability law of Poisson process. So what we do is, very lengthy proof it is, very lengthy proof. So what we do is, see, this is probability law of Poisson process. Let us consider P of x of t equal to n. You know what is the meaning. You consider P of x of t plus delta t equal to n. You know what is the meaning. Take in rough work, listen here. You know, I explained, right? So this becomes this one, right? Let us use postulates of Poisson process. You simplify, when delta t tends to 0, it will become Pn dash of t by definition of differentiation. Okay. So listen here, now I am going to assume the solution of this Pn dash of t. When it is, listen here, our aim is to find Pn of t. So I am going to assume Pn of t be f lambda t whole power n into f of t by n factorial. So more or less like our solution what we need, right? If I prove f of t equal to e power minus lambda t, proof is over. Since I know Pn of t, when I differentiate it, I'll get Pn dash of t. I substitute Pn of t, which I assumed, replace n by n minus 1 and I substitute here. And hence cancelling all. Listen here, cancelling all, you will get this f dash of t equal to this one. Okay. Hence it becomes the integrating, you will meet the solution. Integrating, you will meet the solution, right? You will have f of t equal to this one after integration. If I prove k is equal to 1, proof is over. In order to prove k equal to 1, I consider the solution which I assumed, right? Now I put n0, t0. The meaning is probability of 0 occurrence in the interval 0, 0. And it is sure event, right? There will be no occurrence in the interval 0, 0. So probability is 1. The probability is 1, which is when I substitute both sides 0, n0, t0, I get this. So being sure event, it is 1. Now let us take f of t, fourth equation. Put t is equal to 0. Just now we got answer. K becomes 1. So when you substitute this f of t in the assumption, which I assumed the solution, right? Which complete the probability law of Poisson process, okay? Let us prove next mean and variance of Poisson process, okay? We know E of x is equal to summation x into P of x, which we studied in the first unit, right? Here it is E of x of t, right? Which is equal to summation being process we consider with the timer, right? E of x of t is equal to summation x of t into P of x of t. So we are going to find mean, okay? So we know n takes value 0 to infinity here. And x of t I consider, listen here, x of t is n. I consider there are n occurrences in the interval 0, t. So this is x of t is equal to n, right? Here also x of t is n. P of x of t equal to n can be written as Pn of t. You should know both notation, okay? Pn of t. Just now we proved, right? Probability law of Poisson process. So by probability law, it is lambda t whole power n e power minus lambda t by n factorial. Okay. Now n get cancelled, right? It become n minus 1 factorial. Because n factorial is 1 into 2 into 3 into up to n minus 1 into n. That n get cancelled and this become n minus 1 factorial. Okay. Taking summation is only for n. So take e power minus lambda t outside. See, it is lambda t whole power n. Now substitute. See, actually I have got a summation from n from 0 to infinity. When n get cancelled, it will become n minus 1 factorial. Now n cannot be 0 to infinity, okay? N will be from 1 to infinity, okay? So it is, see, now let us give values to n. Put n is equal to 1. 0 factorial is 1. Lambda t whole power 1. Put n is equal to 2. Lambda t whole square by 2 minus 1. 1 factorial. Put n is equal to 3. Lambda t whole cube by 3 minus 1. 2 factorial, etc. Taking lambda t common, it resembles 1 plus x by 1 factorial, x by 1 factorial plus x square by 2 factorial, etc. We know 1 plus x by 1 factorial plus x square by 2 factorial plus etc. is e power x, right? E power x. So it is e power x is lambda t here. Okay, lambda t. When they say we add powers, it will become 1. So it is simply lambda t. So mean of Poisson process is lambda t. So in order to prove variance, we have to find e of x square of t. You know, you studied in first unit, e of x square is summation x square into probability. Here summation x square of t into probability of x of t. Let us assume p of x of t is equal to n. P of x of t equal to n is Pn of t. Since x of t is n, x square of t is n square. So if you expand summation as it is and you will not meet, you cannot sum up all the answers and you cannot use even expansion. Okay, so we have to adjust it. Okay, you expand summation and you try and you will see you cannot proceed. Okay, so let us write. Let us rewrite it as, see, I can add and subtract, right? Some adjustment. I can add and subtract n. Okay. The next step, see, I consider these two together and this separately. So n into Pn of t with summation separately, n square minus n into Pn of t. Taking n common, it is, right? And this is actually a mean, E of x of t. E of x of t is summation x of t into probability, okay? X of t is n, okay? So this is when you take n common, this is the term. And this is E of x of t. E of x of t, okay? And now next term, and since summation is only for n, I took this outside. It is summation and n minus 1 get cancelled. When you see n factorial, 1 into 2 into 3 into n minus 2 into n minus 1 into n. This n and n minus 1 get cancelled from n factorial. So rest of the term become 1 into 2 into 3 into etc. n minus 2, which is n minus 2 factorial. Okay. When these two get cancelled from with the denominator, it become n minus 2 factorial plus E of x of t. Okay. So it is now I expand summation. When n is 2, lambda t whole square by 2 minus 2, 0 factorial, which is 1. When n is 3, lambda t whole cube by 3 minus 2, 1 factorial, etc. Taking lambda t whole square common, it becomes 1 plus x by 1 factorial plus x square by 2 factorial plus etc. which is e power x, that is e power lambda t. Additionally, the term comes, okay, this term comes. When base same, these two bases same, we can add powers. It will become e power 0 t 1. Okay, it is lambda t whole square, okay, which is lambda square t square plus mean, okay. So that is lambda t whole square plus mean is lambda t. Just now we proved E of x of t is lambda t. Now let us come to variance. We know the formula for variance, which is E of x square minus E of x the whole square. Here it is E of x square of t minus E of x of t the whole square. So E of x square of t is lambda t whole square plus lambda t. E of x of t is mean, which is lambda t. We know mean of Poisson process lambda t. So these two get cancelled, it is lambda t. So variance is also same, lambda t. Hence mean and variance of Poisson process is lambda t. You know, you studied in first unit, mean and variance of Poisson process lambda, right? Here also mean and variance of Poisson process same, which is lambda t. So next comes autocorrelation of Poisson process. What is autocorrelation of Poisson process? So we know we have studied, right? Autocorrelation Rxx of t1 comma t2 is expectation of x of t1 into x of t2. Okay. So to find autocorrelation of Poisson process, what I do is I add and subtract. I subtract and add x of t1 the whole square. Okay. I keep these two together and this become expectation of. Okay. From these two, see, if I take x of t1 common, I will get this answer, right? And since all are independent, listen here, then the process here are independent. Hence, see, I can write E of x of t1 into E of x of t2 minus x of t1. Okay. So which can be written as E of x of t2 minus E of x of t1. And this is common, right? E of x of t1 is common. 1 second. Okay. So it is E of x of t1 is common for these two. And we know mean of Poisson process, which is lambda t. In place of t, we have t1. We know mean of Poisson process, right? Same here. It is lambda t2. It is lambda t1. And this is E of x square of t. We know E of x square of t is lambda t plus lambda t whole square. In place of t, it is t1. While finding variance, we found answer, right? You go through. While finding variance in the last proof, right? Lambda t1 into lambda t1 the whole square. Now let us multiply lambda square t1 t2, lambda square t1 square, lambda t1, right? Lambda t1 the whole square here. It is lambda t1 the whole square. So when you see lambda t1 the whole square term get cancelled, so this is the answer, right? This is the answer. And let us write it as lambda square t1 t2 plus lambda into, we have a minimum. What is minimum of t1 comma t2? If I assume t2 is greater than t1. Listen here, t2 is greater than t1. What is minimum? T1 is minimum. Okay.
So this T1 can be written as minimum of T1 comma T2. Listen here. Let us assume T2 be greater than T1. I have here T1, right? This is the standard answer for autocorrelation. So in order to get this answer, I assume T2 is greater than T1. Okay. So this is the minimum, right? Minimum of these two. Minimum of these two is T1. So minimum of T1 comma T2 is T1. So what is autocorrelation? Rxx of T1 comma T2 is autocorrelation of Poisson process, which is lambda square into T1 T2 plus lambda into minimum of T1 comma T2. Okay. Let us see properties of Poisson process and problems in the next video. Okay. Thank you.